Oh, here we go into lesson 5.2, integrals involving the natural log. And you might look at this and be like, there's no natural log in that. The integral will have it though, and here's why. Think of this logic. Since the derivative of ln of x is 1 over x, then the antiderivative would be, right? So we're saying the derivative of what gives us 1 over x? Ln of x. But there's an absolute value there, and you might be like, wait, what? And of course, always remember the constant of integration. What's the deal with that absolute value? I'm going to talk about that right now, and then we'll get into what happens when there's u. Remember that 1 over x, the function itself, is continuous for all real numbers except x equals 0. We've got a vertical asymptote there. So let's say we wanted to find the area here. Well, we'd need the absolute value bars there, or else we couldn't find the area, because in the fundamental theorem of calculus, we'd be plugging in like -5, and let's say we're going to like 1. You can't take -5 to -1 in ln, because you'd be taking the ln of a negative number, which doesn't exist. So what we do is we take the absolute value, and ln looks like this, and then the absolute value looks something like that. So this function then is covered on both sides by taking the absolute value. That's it. It allows us to find the area on both sides of 1 over x. That's why we have the absolute value. Plain and simple. Okay, so always slap on the absolute value if this can be negative. If this inner stuff cannot be negative, then there's no need to put the absolute value. But if you're taking the AB or BC exam, or have a teacher like me who's pretty forgiving, you don't need to worry about whether the absolute value belongs or not. Just put it there. But some teachers want you to only put the absolute value when necessary. It's only necessary if this can be negative. All right, so what's the integral or the antiderivative of 1 over u? That would be ln of the absolute value of u plus c. That's all. That's all there is to it. You're going to be seeing, and I've got a little note here, a lot of u-substitution, right? That's what's going to be happening. So integration that involves the natural log is great, great for integrands that look like this. U prime over u, or 1 over stuff d stuff. Then we're going backwards. So this is 1 over x, we see that. Here is u prime over u, because the derivative of this involves x squared. Ooh, this doesn't look like u prime over u. What? We're going to eventually show that we can make it look like that. We'll go with that down the road. So you've got equal degrees here, squared and squared. We'll get to that in a little bit. The derivative of cotan is minus cosecant squared x, so a form of u prime over u. Basically, if you've got polynomials in the numerator and denominator, look out for degrees that are 1 less, or even greater than or equal to, but especially 1 less. Degree 0, degree 1. Degree 2, degree 3. This one, we're going to have to use some division. We'll get to that later in the lesson. Or look out for u prime over u. That's the easiest pattern to look out for. Okay, let's keep rolling. Let's actually go into action. If done correctly, a lot of the natural log problems are going to be very boring. You're going to use lots of u-substitution and end up with an integrand where you have 1 over u. That's what's going to happen again and again. What do I mean? Well, here we've got 1 over stuff. That's degree 1. It's like 4x to the first. This is degree 0 because it's a constant. So let u equal what was the stuff, the 1 over u. Use u-substitution. Watch what happens. We'll get du equals 4 dx. Well, I don't have a 4 dx, so I'm going to insert that in there. U-substitution. If you need to review it, go back to chapter 4. Got some great lesson videos on that. So we need to put out the 1/4 to balance that out. So you're now going to have 1/4. 4 dx is du. Watch what happens here. You get du, I'm going to leave the 1 there, over 4x plus 3 is u. 1 over u du, or u prime over u. That is straight up natural log. So it's going to be a natural log of the absolute value of u plus c. And then that's going to be 1/4 ln of the absolute value plugging back in. Now, I want you all, any of you, you and you and you, however many people are watching this, maybe just one of you is watching it right now. I want you to check your answers by taking the derivative. It's very important because you're going to do 2 things. 1, you're going to check your answer. 2, you're going to be reviewing the derivative of the natural log, which we just learned in the previous lesson. So that would be 1/4 times 1 over stuff d stuff. And so the 4's cancel, the c goes to 0, and look what you're left with. 1 over 4x plus 3, the original integrand. I'm not going to do that in any other additional problems, but I want you to do that in each problem, please. All right, here, notice you've got a degree lower than the top. You've got u prime over u, essentially, because the derivative of x to the fourth will lead to x cubed. So u is going to be equal to 5x to the fourth plus 6 du, just straight up u sub, is equal to 20x to the third, just 20x to the third dx, because 6 goes to 0. We don't have a 20 there, so I'm going to put it in the problem. And I'll divide by 20. So I'm left with 1/20th, 20x cubed dx, that's du. So you get du all over 5x to the fourth plus 6 is u. So it's essentially u prime over u. 1/20th, or if you want to think of it as 1 over u. That's going to be ln of the absolute value of u plus c. What did I say? You're going to end up with the same exact boring integrand. That's good. Makes problems easy. 1/20th times the ln of the absolute value of 5x to the fourth plus 6 plus c. And again, please check your answer. Very important. You're going to get so good at differentiating and integrating if you do it that way. All right, so these are slightly tougher problems. 5 times tan x. What? Oh, it's a very classic one. First of all, I factor out the 5. That's just there for window dressing. That's the same as sine x over cosine x, which is u prime over u. If we let u equal to cosine of x, the derivative of that is going to give me, watch, derivative of cosine is negative sine x dx. It's beautiful. So I don't have a negative there, so we'll put in a negative. So I've got negative 5. Negative sine x dx is du. Beautiful. All over cosine x is u. U prime over u. That is the derivative of the natural log. We're undoing that, so we end up with the natural log. Always remember the absolute value of u plus c. Now from here, what I've got is to just plug in for u like we always did. It's not bad. And when you take the derivative of this, you will see that you get back 5 tangent of x. Lovely. Lovely, lovely, lovely. Okay, this next one, I love this one. I love it because u-substitution is very apparent, and it's what I call the heat check. Let me show you what I mean. Let's let u equal to 1 minus x squared, because its derivative is this, but it's not u prime over u. The derivative of the square root is not 4x. So right away I'm thinking maybe ln x is not involved here. Du is equal to negative 2x dx. Nice. Very nice. Well, ooh, I don't have a negative 2. Well, let's bring the 4 out there. I don't want that there. I'm going to multiply by a negative 2. That gives me the negative 2x, right? The 4 has been brought outside. Let me erase that and bring it outside. And so we got to multiply by negative 1/2 to balance out the negative 2x. It's the same as dividing by negative 2, right? Okay, so don't know why I multiplied by negative 1/2. Let's just divide by negative 2. Now what we have left is negative 2x dx. That's du all over, and you might be like, sweet, the square root of u. Pump the brakes. Before you go and integrate this and say, oh, it's the ln of that, it's not. This is not 1 over u. This is not the derivative of ln. This is 1 over u to the 1/2, or u to the negative 1/2. That is not the derivative of a natural log, to be very clear. So make sure, especially on these logarithm tests that you're going to be taking in class, this won't come up as much in the AB or BC exam, but make sure when you're taking your logarithm test, you look out for that problem that's not u prime over u. It's often a trap that teachers will put on there. I put it on my test because I want my students thinking, not just memorizing a formula and applying it 8,000 times. So the integral is negative 2 times, we'll add 1 to that, normal power rule, and divide by 1/2, the power we just got, which is the same as multiplying by 2. That's negative 4 to the 1/2 is the square root of u, 1 minus x squared. If you take the integral, if you take the derivative of that, you will end up back here with the 4 in there. All right, just before I say goodbye in this video, one quick thing to see. This problem here, at the end, you technically did not need the absolute value because anything raised to the 4th is positive. Times 5 is still positive, plus 6 is still positive. So technically, the absolute value is not needed because anything that comes out of that is positive. So I just wanted to mention that. All right, math, awesome, calculus beast. I don't know where that came from. I will see you in the next video. Peace.